Hi everybody. What I'd like to do today is to give you a very graphic demonstration of the power of nonlinear dynamics. Now, human beings first got the control of linear dynamics, materials, with Isaac Newton. We got some deterministic rules that all seemed easy. We could look at the planets and you could say where everything was going to be in the future. It seemed to be getting the hang of things. And then it all seemed to start going wrong with the laws of electromagnetism. We've got this ethereal, something different from the material world. But it's still all fitted together. We get the electric motor with the solid physical parts, and then the electrical fields, and the magnetic fields, but it still all seemed to make sense. And then along comes Einstein and says, well, this is just a relationship between matter, the material world, and space. And then comes quantum mechanics. And this doesn't seem to fit together with what we've got. But it all seems to work in its own domain. As long as I stay in the small atomic world, it all seems to work correctly. But particles seem to come and go as they please. They can be in two places at once. They can disappear. Now, this is still a problem. We've got two sets of physics, and they both work. One gives us computers, TVs, cell phones. The other gives us machines. It tells us how the planets work. Or does it? What nobody tells you, or any of the students at university, is that Newton's laws of motion and Einstein only works for two bodies in the solar system. If I get to three bodies, the sun, the earth and the moon, they don't work. There are no equations that do work. That's a real shock. And that's swept under the carpet. And you can hear a very good English mathematician called Ian Stewart stating that in our time. It simply doesn't work anymore. But if we look the other way, who cares? Well, I care. Because it means that we don't have a description of the solar system. The solar system has the stability, the order of the orbits, but the chaos in the rings and belts. Nobody can describe or say what's going to happen to all the little pieces of ice in the rings of Saturn, or the chunks of rock in the asteroid belt. Well, I don't think that's acceptable. That means that the solar system can't go into the physics book. People are really shocked when I show them this physics book and ask them to find the solar system. And all they find is that we get a description of one planet and the sun, but the solar system as a system, a unit, it's not in here because we've got chaos. Physics, classical physics, by definition, can't have chaos. That's not deterministic. So we've got this mix of non-deterministic and deterministic. Where do we put it? And there's another problem. All the complexities that we see with life, living things. Every layer of fossils, more complex, diverse than the last. Physics has no explanation for that. So something's wrong. We must have enough information, but we've got it all mixed up. So what I've done here in Taiwan is to work with a team who've just rearranged everything, put it so that we can make sense of it. And what we've done, we've just stated reality. We've put physics here. Classical physics, a relationship between energy, matter, space, time. Now some of you will recognize that as general relativity, and the relationship between these, special relativity, and quantum mechanics. There's just three entities that start it all off in the standard model: the quark, the electron and the neutrino. Just a discrete entity in a relationship with space, but no volume. I don't need volume to generate volume. I just need entities that repel each other when they're attracted to each other. Two things happening at the same time. It's a relationship. I must have the pushes and the pulls. So if I start to say that matter, when it's very small, is not the same as when it's very big, it has a different set of rules. And these rules are just pure mathematics. Mass, a relationship with space, the Higgs boson, relationship with the Higgs field, no intrinsic substance. It starts to be logical. It might not be classical logic, but who says it all has to be just this kind of physics or this kind of physics? This is the problem. You can hear Roger Penrose, Brian Greene, Lawrence Krauss and other people say, well, there's a missing part of physics that has to explain all of this. But why does it have to be the missing part of physics? If it all starts with the standard model as non-physical components that generate the physical world, why does it all have to be physics? What we find in the nonlinear world here, the mathematics of complexity, is that this mathematics has nothing to do with the components or the fundamental laws of physics which sit down here. That's the atomic forces and the gravitational forces, Newtonian mechanics. If I want to explain anything complex, just three bodies, the Earth, the Sun and the Moon, I have to have a relationship between this, which can be chaotic or ordered, and this. And now I can leave my physics here, the Earth and the Moon, and move out the three bodies, the three-body problem and the solar system. My contradictions disappear. I can also move out the atomic contradictions, which very, very quickly, just at three entities again, a cup of water can't be explained by physics. There's lots of programs on the internet now, you can see, it'll explain that to you. Chemistry, the weather, atomic patterns. If I move them out here, this is just the simplicities. My contradictions disappear. All I've got here are stars and elements. Now, atomic nuclei, elements and stars, just generate each other. It's not a star. It's a something coming into existence that simply wasn't there before, and that existence is an interdependence between what's coming out of the atomic nuclei and the gravity holding them together. And the nuclei is an interdependence, a relationship between neutrons and protons, the electromagnetic force repelling, and the attraction of the strong nuclear force. It's a competition, but I've got two. I've got to compete or cooperate at the same time. Now this brings in something we call strange loop. Two things that generate something different, something which is different, something that wasn't there before, stars and elements. When that star dies, what dies is the interdependence between these two, and the elements are released, and a new evolution takes place. But this time, because of all the different masses of the elements, we get different components, Earths, gas giants, each one just relationships. So if I stop saying that physics is the answer to everything, but I need this nonlinear mathematics and the relationship with both kinds of physics, the Earth holds itself up against the repulsion of the particles which the gravity is trying to pull it together. I get an interference here. I get a relationship which does describe cosmology, galaxies, solar systems, three bodies, the weather, snowflakes, chemistry, and in the middle, the hot spot, life and viruses. I must have two. They must compete or cooperate to be self-organizing, and they self-repair. But better than that, they're self-improving. And if you don't have two, I don't get self-improvement here. But now I've got some logical answer to how everything fits together. I've got a universal kind of behavior. Quantum entities can behave exactly how they want down here. Classical entities can behave exactly how they want. But I get universal behavior here. Things bring themselves into existence. The first particle is just a relationship between energy and space. But very quickly, if I go over into atomic nuclei, I get this polarized behavior. Two components, the Earth and the Moon. Again, everything is just two. The Earth, a relationship between what's happening at the quantum level, the atomic level, which is repelling itself, and what's happening at the gravitational level, which is holding it together. It's that loop, that competition between them. But as soon as I flip over into three components here, and I add electrons, which get shared between atoms, and I fly off into chemistry, I've got something where I need to add another set of mathematics to give me an explanation. And the same at the gravitational level. When I've got rings and belts, I've got harmonization, I've got something completely different. And the stability which I get here, it's always a relationship between something that's stable and something that's variable. I get the stability of the nucleus, the variability of what happens in the electrons. I get the stability of a gas giant or the sun. Then I get the variability of what happens in the planets. And I must use mathematics, pure mathematics of harmonization and resonance and perturbation theory to give me an explanation here. But then I get the stability of something like the Earth and the chemistry, which can then take place, and I can carry on then building systems of interdependent systems, which just become ever more complex and diverse. So nonlinear dynamics is extremely powerful. It gives us a logical explanation for the reality that we see, simply a relationship between the physics down here, the mathematics here, and one consistent set of laws of mathematics, not trying to describe it using a consistent set of laws of physics, which we don't have. Now, just to show you how powerful this mathematics is, this is the mathematics which is not to do with quantifiable measuring things and units. It's to do with what's in between them. And the person who wrote the first really good book on this, Robert C. Hilborn, he states that scientists are going to find this very disturbing. This is the mathematics that sits in between the entities. It's the ratios which determine what's going to happen. So let's just see that at work. It's something in between here. So if I go and give myself a little diagram like this, space and time, the relationship between space and the gravity generated by the matter here is going to give me a star, the energy released by the strong and weak nuclear force. It's a relationship between them which is causing that star. It isn't just gravity making the star. That's the mistake. If you say it incorrectly, you can't understand it. And the Earth here, relationship again between the space and the electromagnetic repulsion which holds the planets up. And a relationship between these two, which gives me elements and objects. And I can see I've got three entities. I must have three to get complexity. Same as if I've got the Earth, the Sun, the Moon, or a neutron, a proton, and electron. As soon as I get complexity, it all changes. Three generations of matter. Three primary colours. The colours don't exist outside your head. You only need your brain to generate three before you've got all you need to see all the colours. You make the colours inside your head. They don't exist outside it. And we just go on and on and on, becoming more and more and more complex until we get to conscious thought. That must be this feedback loop that we've got here again. That, Noam Chomsky will already tell you, has to do with language. Language is a mathematical structure, a universal mathematical structure. It's nothing to do with the individual languages, just the same as cultures and religions and nations and all that strange behavior. It's nothing to do with the individual behavior. It's just a universal mathematical structure which occurs in every society on the earth. So here, if we've got language, we think in language. We generate thoughts in language. So conscious thinking is the interference between thoughts and the language they generate and the thoughts that they generate. Ad infinitum. So Noam Chomsky already knows that, but he doesn't have this mechanism. Now, I first came across this mathematics more than 20 years ago with this feedback loop, working on race motorcycles like that. There's Mr. Dean Ashton in Superbike, and Honda very generously gave us a race bike just for the training team. But we came across this loop. What happens in the exhaust system of race motorcycles is non-physical. And I went to find a book that would tell me what would happen. How do I design a good exhaust system? And there were none. The engine, dead easy, Newtonian mechanics, it's got physical parts. But what you find is the strength of the pulse that's in the exhaust system dramatically affects what's happening inside the engine. It draws out all the dead gas and sucks in some clean gas. But each one drives the other. The stronger the pulse in the exhaust, the stronger the engine, the stronger the pulse it gives to the exhaust. It's just a feedback loop. Now, my little team went and bought that book many, many years ago, and ended up building a Honda, which there's the works Hondas. Now, Honda have a huge amount of money. Honda Britain, 1, 2, 3. There's Tony Scott, the guru of all motorcycles. And there's the training motorcycle, faster than them all. So that's the power of nonlinear dynamics. And everybody laughed at us for reading books like that. They didn't laugh when they saw that. Now I'm going to give you a graphic demonstration of non-linear material. If you think the material is just to do with physics down here, and you ignore this, you're not going to make good material at all. This has nothing to do with the physical components. It sits outside it in something called phase space. Well, let's change your mind. If I take something like that, now this is solid lead, 10 kilos of solid lead. If I want to support that with some metal, some aluminium, linear, I would use a tube or something like that. Well, there's carbon fibre. This is the best stuff around. We think this is really it, but it's too heavy. Watch this. If I put some non-linear material here, put my tube on here, 15 times heavier. This is how much non-linear material actually weighs. If I show you my little box of weights there, 5 grams, 2 grams, 1 gram, 1 gram of material. There we are. So if you take your 1 gram of material, there, a little piece of metal, and you have to build a structure that would fill all that space. That metal is just so thin. If you try and make a tube, well, we tried it with aluminium cans, which are very, very strong, but the aluminium is just so thin. I tried to make a structure just with my 1 gram, but when you put this onto it, it simply doesn't work. Now, let's just show you, put that in perspective, how much the ground is. If I use tissue paper, let's put a tissue paper on here. So you can see. Now, this is non-linear material. It's nothing to do with the material, the geometry, or the physics down here. So let's show you what happens when I put this onto. What do you think is going to happen here?
I think it'll hold it.
Are you sure? Let's show you the power of non-linear dynamics. There you are. Absolutely astounding. Now, if you've never held a tissue paper in your hand, you try it. Now, I have no intention whatsoever of telling you the secret of how that works, because companies here in Taichung are paying a lot of money to find out how that works. And they're really shocked that it has nothing to do with physics. It's what's happening in between the physics. And once they've got the secret of that, they can increase the strength 10, 20, 30 times as much as that. So that's the power of nonlinear dynamics. Not only will it change our structural world, it will change the whole way that we think about reality and teach reality to students. Because when you teach like this, I have a set of basic principles. I can start at the bottom with my universal behavior and just work up. And you'll see this universal behavior again and again and again. It works at the quantum scale. It works at the gravitational scale. It's simple to complex. 1 and 2, no problem. 3, it all begins to change. And that's just like drawing a hexagon inside a circle. 1 radius, 2 the diameter, it all works. If I want to get back to 0, if I go on a hexagon, I get 3, I get back to 0. But if I walk around the outside, I get 3.142. I get 2 answers which are correct. Now, if you teach like that, and it's the interference between that mathematics which makes the whole thing work, children understand, and you can teach that at a very, very basic level. I've got logic. At the minute, there's no logic. We need an explanation of how the works of Shakespeare, you and I, crawl out of the rocks and water of the early earth. Something which just gets ever more complex and diverse. Something which needs this mathematics with this physics, a relationship between them. This physics only has entropy. It's the dead, lifeless stage of which chemistry, cosmology, and life play itself out. But while there's lots of people saying that we should be looking here for the missing part of physics, you can't see the big picture. So I think this is going to bring a revolution which Roger Penrose tells us we all need, a new description of space and time. Loops. And look how it works. If I take mathematics and describe the forces which make space, the distortions of space, gravity, magnetic fields, electrical fields, 3 again. In imaginary numbers, if I square them, they give me negative numbers, energy, which if I square them, give me positive number, matter, which gets into events and interactions, which brings me back to time, interactions, events which will be both positive and negative. When I have positive composition of snowflakes, life, stars, I must say that's positive time. When I have decomposition, negative time, positive and negative matter, positive, negative waves of energy, positive and negative imaginary numbers, the fields and forces that drive all this. I get back to the beginning when I get matter producing events. And these events produce more forces, and not just the fundamental forces, but the forces that you and I feel that drive us all the time in the events which we call our lives. And those will show up as universal behavior. My individual behavior is very different from my polarized behavior, which is very different from my group behavior. I must have something to trade or to offer. Now, the fact that people behave like this shows up in books, mathematical books, critical mass. We get to the critical state, that's using this mathematics here and the power laws, the First World War, the little tiny event, the little grain of sand, the randomness at the individual event that causes the order of the structure. So that First World War started, it doesn't matter what that event is, it's already waiting to happen. The fact that we show universal behavior cannot be any surprise. And our language, which is so important for creating our thoughts, and our thoughts which create our language. Now this relationship between randomness and order shows up in the prime numbers, mathematics, which give the order of the composite numbers. And Marcus Sauter already calls prime numbers the atoms of arithmetic. He really means the atomic nuclei of arithmetic. So this really does bring a dramatic change where I can describe science and mathematics. All these books now have a universal relationship, the relationship between this mechanics, quantum mechanics, and classical mechanics. And quantum mechanics sits in at the bottom. I can't have classical mechanics if I don't have quantum mechanics holding everything up. But again, I get this relationship. What I know about the quantity here, I don't know about the position of momentum. What I know about the position of momentum, all the quantities are different. It's just the same thing. Now these strange loops and strange attractors which we have up here, the strange attractor and repeller, the forces which are generated when I get more events here, I've just got a loop here between all this relativity. So what I'm saying here is that this is the universal theory of relativity. It's all relativity, even for the first things to exist, stars and elements, just a relationship between the two. There's nothing that's not a relationship. We were all made of matter like neutrinos. We couldn't even detect that the Earth existed if we don't have a relationship. Well, I think that's going to change everything. And people who are not paying attention to this are going to be left behind. Thanks for listening. Bye-bye now.